Okay. Yeah. All right. So let's do it the mathy way. So I was talking about my friend who had taught third grade for years over Irwin Valley. And then she had kids. And then when she went back to teaching, there was one opening, and it was teaching sixth grade math. And she said, of course I want to teach sixth grade math. And she was terrified. She doesn't teach that anymore, but she had some upper level kids, and this is the kind of stuff they were doing. They were doing elimination and substitution. So even though you might have sixth grade, if you've got some kids that are working a year ahead, you're going to have some upper level kids, right? And so this is the kind of stuff they were doing. So she was at my kitchen table, and I was helping her, show her how to do it, because she didn't remember. All right, you ready? So it's 2 equations, 2 unknowns. Let's see if we can clear out the cobwebs. So if we add the pigs and the chickens together, how many do we have? How many animals are in the barnyard? 24. All right. Here we go. And then we've got 4 feet for every pig, 2 feet for every chicken, and then how many feet do we have all together? Feet, legs, feet. 80. So you guys remember setting up 2 equations, 2 unknowns? I know some of you do because you did it with me. All right, so, Tasha, how you want to do it? Elimination or substitution? Do you want to solve for one variable in terms of the other? Or do you want to get one number so I can't remember what you like to do, where they cross off? Cross off? All right, so if you decide you want to do elimination, you want to get the same number but of opposite sign in front of one of the letters. You good? What's your name? I have a name. Allison. Allison, what letter do you want to eliminate? The P or the C? The P. All right. So with a positive 4 in front of the P downstairs. So what do I need in the P on the equation upstairs? Same number but opposite sign. -4. Okay. So we need a -4. So what we're going to do is we're going to multiply. Where did my backpack go? Let me do a little different color. We're going to multiply every single term in that second equation by -4. All right, don't wait for me. You guys can do it. A different color so it shows up. I don't know if it'll show up on the video. You wanted me to experiment, so let's try different colors so it shows up on this camera. Let's see. See if orange will show up. It looks black to me right now, but so here we go. All right, here we go. So we're going to multiply both sides of the equation by -4. So that means each piece. So -4, you get one, and then you get the -4 as well. So we got -4p plus -4c. What's 24 times 4? Was that 96? -96? Sorry. Okay. -96. And then we don't do anything to the other equation. It just stays the same. Do you guys remember what we do next? How do we get rid of the P? Which one do we do? Yeah, you're going to cross it off. You're going to add the 2 equations. So -4 plus 4 is 0. So those go away. And then -4 plus 2 is what? -2c. And then what's -96, 80? Negative what? -16. And then how do I get c by itself? I have a 2 hanging out in the front. What will undo multiplication? Divide. Yeah. So there we go. There's our c equals 8. And if you know 1, you can solve for the other, right? Because you know there's 24 altogether. So then you would just subtract. That one okay? Is that bringing back memories? All right, so that's what's called elimination. That's like a advanced 6th, 7th grader. You probably reviewed it maybe in Algebra 1. Does that ring bells? Yeah. But that is definitely something that an advanced 6th grader is definitely on their plate. You know, scratch the surface with that. All right, so that's one method. Let's do substitution. So I'm just going to do it on the back of this because I'm running out of room. Do I have a room? Yeah. So we had same equations. So P plus C equals 24. 4P plus 2C equals 80. So no different, right? Same equations, right? Let's try to straighten that out. All right, so elimination, you solve for one variable in terms of the other. So Hayden, what do you want to solve for? Do you want to say P equals something or C equals something? C, okay. So I'll do a little scrap paper over here. So this is my scrap. So Hayden said he wants to get C by itself. So if I subtract P from both sides, do you see that C is 24 minus P? Does that make sense? Okay, what do I do with that? It's called substitution. So what do I do with that C? Yeah, perfect. You plug it in. You substitute it into that bottom equation. So when you do that, something really cool happens. So this equation now is all in terms of P. Is this bringing back memories? We're clearing out the cobwebs? It may have been a while, but you probably have done this. So what do we do? How do we solve it? What's the first thing we got to get rid of? Which what? Yeah, the parentheses, right? You got to distribute. So let's distribute that. So we got 4P plus 48 minus 2P equals 80. If I make a mistake, don't let me continue. I have my glasses on. But they keep steaming up, so it's kind of a lose-lose. How many P's we got? If we got 4P minus 2P, how many P's? 2P. And then plus 48 equals 80. Then what do I got to do? Subtract the 48, perfect. So 2P equals, what is that, 32? Is that right? Okay, and then what do? Divide. So we got P equals 16, and then is that what the answer should be, right? Okay, and then, well, they're 24 altogether, so then you can just kind of subtract. I do not care how you do these. Find a way and love on it. So drawing, substitution, elimination, table. Sometimes people do like this little mini shortcut method. You figure out your own method. I don't care how you do it. So that's the first question on the OWL. It's like a pigs and chickens question. Remember, I don't make those up. I explained that to you, right, about the homework, right? They're here on the back of the, they're there. This is where they come from, okay? So practice one more. Try the bicycle one. Isn't there a bicycle, tricycle one? Yeah. It doesn't say pigs and chickens, but you got to just recognize it. So go ahead and try this one. I don't care how you do it. Find a method and love on it. It will definitely be one of the first questions on the final exam, is a pigs and chickens type question, and it just says use the method of your choice, show supporting work to show your answer. So on the final last semester, I think the answer was only worth 1 point, and then the work was worth 3. So you could have missed the entire question and still got 3 out of 4 points. It's the work, right? Just don't show me an answer. I mean, I know you can do it on your calculator or your app. And I don't know if you answer it, so we'll check it together. I'm going to draw it because I think drawing's easier. But do it any way you want. If there's like 300 seats, you probably don't want to draw it. It takes too long. bicycles. Did anyone get an answer yet? I don't know what it is. Did anyone do it? Nobody cares if you're wrong. Did anyone do it? Yep. Did you do it, Amber? What'd you get? 24 and what? 8? Did anyone else get that? I don't know what the answer is. Just see if it's the same thing. I don't know. Let's try it. Let's see. 32. 68. Yeah, that's what I got too. I just like did it in my head. So try it like if you're like, oh, that's an easy way. Then try it one of the mathy ways. Like just for kicks, if you've done it one way, just for kicks, try it another way. See if you can do it with the table or see if you can do one of the mathy ways. It's up to you. Just try it. It's fine. What way would you do, Tasha? The elimination for chicken? Yeah. That's good. Just try it. Like change stuff. Which way do you do it? The drawing? It's easy, right? Yeah, I like the drawing.
I work at
You do what?
I work at a bakery. So
Oh, cool.
that's kind of like what we.
Oh, yeah, they'll draw, right? They'll draw the picture.
That's what my brain just thinks of it.
Yeah, and that's good, because that's their go-to, right? Automatically, that's what kids will start doing, because they draw tables, they draw pictures, they draw charts. This is their go-to. Absolutely. Lizzie, what'd you do? Drawing. Now, like, I drew all the wheels, but technically, like, there's a shortcut, right? You could say, all right, if you make them all into bikes, how many wheels do you have?
64.
Yeah, you'd have 32 times 2, so you'd have 64, right? So without drawing the wheels, I know there'd be 64, right? So then if you wanted, right now, you can say, okay, every time I change a bike to a tricycle, how many wheels do I add? 1, right? So I've got 64, so now I've got to change some bikes to trikes. Are you with me on that one? All right, 64. Then you could just, at this point, go 65, 66, 67, 68. What do we got to go up to? 69, 70, 71, 72. Done. Do you see it? So those are my tricycles, and then the rest are still bicycles. So 1, 2, 3, 4, 5, 6, 7, 8. That's what Amber said that there were. Why did I put a C? That should be a T for tricycles. So 8 tricycles, and then the rest have got to be bicycles. Does that make sense? Tasha, which way you want to try it? The mathy way? Did you do it? Oh, did it work? Okay, cool. Did anyone try like the mathy way and you're struggling a little bit? You want me to do the method you were trying? It just didn't work out? Because sometimes there's like you just make a little math glitch and it kind of ruins it. It ruins the whole problem. John, what way did you do it?
I did it one of those, so like if you go up, I'm not sure.
You did the elimination method?
Yeah.
Yeah? Did it work? Does anyone want me to do the math way? David, which way do you want to do it? Which way did you try it? What? Which one did you try? Did you try that one? Or did you try the one that's on the back? Did you try elimination or substitution? You heard me. Right, hold on. All right, did you say? Oh yeah, you weren't here, so you're like, what is she doing? Yeah. Yeah. You turn up all the lights first, and then you just look to see how many wheels you needed left, and then subtract it. Yeah. Good? Stop. Perfect. Makes good. All right, are we good? Can I move on? All right, I did it as a little map. It's perfect. I love it. All right, I want to be able to get stuff done so you can get the wow done. All right, so let's try the coin problem, because do you have a coin problem on the homework? Yeah. Let me just show you. I try to bring in papers. Coin problems. Well, here, you try it first, and then I'm going to show you some of the papers that parents have given me with their kids. They're like, oh, look at this coin problem that my child brought home. They're really popular. So I'll show you some coin problems that parents that have taken this class have brought in. They're like, oh, look, they did coin problems the other day. I'm like, oh, can I keep that? Yeah, your kids. Bring the sheets in. I want to see what you're doing. Good stuff. Hayden, did you have a question?
I was gonna, we'll ask.
Oh, yeah.
I was just, thought.
Yeah, that's what you did. You did really good. Yeah, that's exactly what you just did. Yeah, cool, right? Now, that only works because there's a difference of 1. If there were a difference by 2, like the pigs and chickens, then you'd have to see how many you need and then divide by 2. You see what I mean? All right, did anybody get an answer for this? I don't know what it is. Struggling with this one? The coin one? You gotta organize it. If you try to guess, check, like just stab in the dark, you're probably gonna miss one. Here, I'm gonna show you. Let me show you something that a parent brought and gave me. Hold on, if I can find it. Ah. You what, huh?
I don't get how you're supposed to make 25 cents with dimes, nickels, and pennies.
Oh, well, I'm gonna show you. Okay, you ready? Let me just show you this chart, and this might help. I don't know if I can zoom in on this. Oh, look at that. Whoa. All right. So do you see, like, this chart? Now, it's kind of hard to see it. But they said quarters, dimes, and nickels. And then they started the kids off. This was already in there. 1 quarter, 2 dimes, 0 nickels. So they did all the 1 quarters first. Then they did the most dimes you could get next. Do you see how, like, 2, 1, 0? Do you see what I'm saying? And then they said no quarters, most dimes, and then they just decreased the dimes by 1. It's very methodical the way they're showing these kids. Like, look at this one. Look at this kid's example. Look, the most 4, 3, 2, 1, none. They're very methodical, so they're not going to miss any. Do you see what I'm getting at? So try to organize it instead of just like thinking of different combinations, because you're going to miss one if you do that. Do you know what I'm saying? Like if you're like, oh, I know how to do one of the ways. You got to be really systematic, and that's a big mathematical practice, is organizing with diagrams, pictures, charts. I have a bunch of these that parents have given me. Hold on, see if I can find another one. I remember there's one that wasn't in color. I have a bunch more. They're the same thing though. Yeah, this one, this kid named Ryan, like they organized it with little nickels, pennies. They're all so cute. He drew out the coins. A bunch of them. Okay. Oh, we'll have penny. All right, so we have dimes, nickels, and pennies. Is that how you started your chart? All right, which you gotta tell me. I gotta learn the name behind. Now I already know Tasha. Maddie. Okay, what's the most number of dimes we could use to make 25 cents? Keep going. Yeah, we can use 2 dimes, right? So we could use 2 dimes, and so if we have 2 dimes, what's the most number of nickels that we would need with 2 dimes? 1 nickel, and then how many pennies? Yeah, then we would have no pennies. Are we okay with that? All right. So we could also do 2 dimes, no nickels, and then how many pennies? 5. Are there any more combinations with the 2 dimes that I'm missing? No. So now we're going to reduce that down. We're going to be very methodical. We're going to reduce it down, and then what's the most number of nickels that I would need now? If I have 1 dime. For 25 cents? Yeah. Does that make sense that it's 3 nickels? Yeah. Okay. And then how many pennies? None. So now we're going to just keep reducing those dimes down by 1. So 1 nickel, we're going to reduce the nickels down by 1. So 1 dime, 2 nickels, how many pennies? How many pennies? 5. 1 dime, 1 nickel, how many pennies? 10. Do you see what I'm doing? I'm keeping the dime, I'm reducing the nickels, and then I'm just maxing the pennies. Have I covered all the combinations of 1 dime? All right, so now we got to go to 0 dimes. So what's the most number of nickels that I would need for 25 cents if I have no dimes? 5. And then no pennies. Can you guys take it away from here? Then you got to just keep reducing the dimes. Wait, wait. I'm reducing the nickels. I keep saying the wrong coin. Reducing the nickels, so be very systematic about it. So every time you reduce a nickel, you up a penny, right? Okay, you do it, I'll do it, and then we'll count the ways. So did you cover them all? Did we get them all in? How many ways did you get, Lizzie? Okay, take your time. Libby, did you get them all? Do you think we covered them all? I think we did. Yeah, we got the most number of dimes, and we covered all those. And we got the most number of nickels, and then we decreased by those. And then we got the most number of pennies. How many ways did you guys get? 12 ways, right? If you just try to guess, like just guess, like, oh, I forgot we could do this many pennies and this many dimes, or you're going to miss one. So that's why they have these kids learn very early on to be very structured in their forming these combinations. So this one, if 8 coins total 50 cents, what are the coins? So you've got 8 coins, any denomination you want. You got pennies, nickels, quarters. I was thinking about, I know I thought of one in the car yesterday, and I thought of another way. I think there's 2 different combinations that you can do, I think. So we'll try it. If you do one way, see if you can think of another way. You got 8 coins all together. So here, it's like, I'm running out of room. You got 8 coins. 1, 2, 3, 4, 5, 6, 7, 8. So fill in quarters, pennies, nickels, dimes. And then I'm going to do it over here again. 1, 2, 3, 4, 5, 6, 7, 8. Go ahead, try fill them in. This is just just thinking about it. I had to chew on it. I was thinking about it in the car the other day. I'm like, God, what? I thought of one, and then I thought of another one, but I can't remember what. That is that. One done. How did you do one of the ways? 2 dimes and 6 nickels. Calvin said 2 dimes. So it's $6 nickels. Okay, 10, 20, 30, 40. Yeah, that's perfect. That's one way. Woo-hoo. All right, you got one way. Did anyone do it a different way? What's your name? Alyssa. Alyssa? All right, hold on. You got 1/4, 2 dimes. Yeah, we gotta have some pennies in there, right? Because of that quarter. So 30, yes, 40, 50. I think I thought of that one in the car, but I'm like, there's gotta be one with a quarter in it. I think that's it. I don't think there's another. But this was just like, I mean, I just drew out the 8 coins. Did anyone just draw out the coins first? I mean, that's what they're getting at. You're just modeling it right away. I know I have to fill in denominations with these 8 coins and then just trial and error, right? If you picked a quarter, you knew the other one either had to be a dime or 5 pennies, right? Because it had to add up, you had to get rid of that denomination of 5 with a quarter. So then, I think that's what I was trying to figure out in the car, if there was a way to make this 5 cents and what to do with the rest, but I couldn't think of it. But I knew there had to be a way with a quarter. Are you okay? You guys with me on this? So you have one of those on your wow. So we're gonna skip the patio, because that's not on this week's wow, that's on next week's wow. And we're going to skip ahead, and we're gonna do the handshake problem. All right. Patterns. In my